This topic is all about quadratic regressions. We have the Algebra 1 topic 8b. Write using technology quadratic functions that provide a reasonable fit to data to estimate solutions and make predictions for real-world problems. Here's the steps to do that in the TI Inspire. First, you will click this icon for Vernier Data Quest. Copy the X and Y data that's on your paper into the table by clicking this. And then you want to click this icon to graph the points. If you don't do that, it won't let you do the menu stuff. You want to click Menu, 4 Analyze, 6 Curve Fit. Choose 1 linear, 2 quadratic, or 6 exponential. We're talking about quadratics right now, so you would click 2. Enter to get the coefficients. And then you would write your equation given what is in the box for your found coefficients. You can also do the same thing on Desmos. Copy and paste the table of data. You click the plus sign. Type Y1 and then the tilde mark, the little squiggly line. And then for quadratics, you do ax1 squared plus bx1 plus c. If you don't put the ones next to it, it'll say error. For square root, you would just write a sqrt parentheses bx1 minus h plus k. Let's look at this example. The area of a rectangle increases as the width measured in meters increases. The table of values below shows the total area A of W for the corresponding width. Find a quadratic regression equation. So we'll go ahead and put this in using both of those techniques from above. First, let's do it on the TI Inspire. So the first thing you want to do is click this beaker button, Vernier Data Quest. Click this table button, and then input your values. Once you do that, click this Menu, 4 Analyze, 6 Curve Fit, 2 Quadratic. You scroll down and it gives you A, B, C, and the determination coefficient. You would record those on your paper. Let's do the same thing now, except for now we'll do it on desmos.com/calculator. You want to click the plus sign and click Table. And then you'll record your values for X and Y. Y1 tilde ax1 squared plus bx1 plus c. And then it gives you the values. And we'll record that on the paper. Now notice these values are slightly different for the determination coefficient. It's just they rounded in different areas. So for A we can put 6, B -19, C 30.5, and then R squared, the determination coefficient, 0.993, and then 4. Okay, it's very close to 1, so that's considered strong. But it's not perfect because it's not 1 here. So the quadratic equation would be y equals 6x squared minus 19x plus 30.5. Using the found formula, and once you find the area where the width is 7. To do that, we just plug in x equals 7. So y equals 6 times 7 squared minus 19 times 7 plus 30.5. And you put that in the calculator, and then you'll get 191.5 meters squared. And then once you find the width when the area is 36, we'll just set the equation equal to 36 and solve for x. We could use technology for this one. And if you solve this in the calculator, you should get 3.5 434 meters. A way you can put this in a calculator on Desmos is to set all of this equal to 0 and then find where it crosses the x-axis. You could also solve this using the quadratic formula. Let's also look at 2a.4e. Formulate quadratic and square root equations using technology given a table of data. Let's look at number 2 on this page. The number of times that a school has won the National College Basketball Tournament is related to the number of times that the school has participated in the tournament. Here's the data for several schools. This relationship can be modeled by y equals 0.00481 x squared minus 0.0964x plus 0.208, where x is the number of appearances in the tournament and y is the number of championships they have won. Notice in this problem you don't have to do anything with the table at all with Desmos or TI Inspire because they already give you that equation. It wants you to just interpret the equation and apply it. On A, it says, what does the y-intercept of this function represent? The y-intercept basically means with 0 appearances, you have 0 championships won. With the next one, with B, it says, according to this model, would you expect a school of 15 appearances to have won how many championships? So 15 appearances is somewhere between here. If you plug that into the formula, it's still 0. So you just write 0 wins. Using this model, a school with 59 appearances in the tournament would be expected to have won how many championships? Round your answer to the nearest whole number. So we'll just plug in 59 for x, evaluate to get your y value, how many wins. And from here we would just plug that into the calculator. And when we put that into the calculator here, we get about 11 wins. D, based on this model, how many tournament appearances would you expect from a school that won 2 championships? Round your answer to the nearest whole number. So this one, it gives you y already. Just like they gave you x on this one, since they gave you y, you're going to be solving instead of evaluating. So we'll put 2 equals the numbers, and then we're going to solve for x. The first thing you want to do is just subtract 2 from both sides. And then you would have 0 on this side. And then you'll graph it and find the x-intercepts. So if we zoom out on the graph, after we've plugged this in, we have about negative 11 and about 32. It would be unreasonable to say that there would be negative appearances, so this is an extraneous solution right here. But 32 would work, so you could write down 32 appearances. That's how many tournament appearances you would expect from a school that won 2 championships. Okay, use the information that you gathered from these 2 examples and try number 1 on this page now. You can use the TI Inspire or the Desmos calculator, whichever way you'd like to do for the practice.